Hi. Today we're going to talk about analyzing data. The first thing we're going to talk about is measures of central tendency. So the three measures of central tendency are mean, median, and mode. You probably know a lot of this already, so hopefully you won't have a hard time with it. But mean, of course, is an average, and that's the sum of all the data values divided by the number of data values that are there. The median requires a few steps. The first thing you have to do is put the data in order from least to greatest. It's really important. It's not true if they're just in a random order. And then you take the middle number. So if there's an odd number of data values, then there's only one middle number, and that'll be the median. However, if there's an even number of data values, there'll be two numbers in the middle. So you take the two numbers in the middle and then find the mean of those. And the mode is the data value that occurs most frequently. That can be no mode, one mode, or two mode. If there's any more than that, then we would just say that, there aren't any because it wouldn't be significant. Okay, let's take example 1. That is supposed to say frequency, not frequently. The frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. Frequency table, there we go. What are the mean, median, and mode for the job offers per student? So this is a frequency table. So this is not just a huge list of data. So we have the number of job offers here. And then we have the number of students who received that number of job offers. So for instance, 4 students received 2 job offers. Okay, so what is the mean? Well, the job offers need to get multiplied by the number of students, because really what this means is that you had all of these job numbers listed in a big group. So you had 0, 0, 1, 1, because there's 2 1s, there's 4 2s, there's 5 3s, like that. But that's a kind of ridiculous way to have to organize this data. It's much better if it's in a table. So that's why they often put them in tables. Okay, so the mean is going to be 2 times 0, 2 times 1, 4 times 2, 5 times 3, 2 times 4. And then there are 15 altogether because there's 15 students. And that's going to give us 33 over 15, which is 2.2. So the mean job offers received by a student then is 2.2. Okay, for the median, there are 15 data values. Now, you don't want to have to write out this whole list of numbers like I just started to do up there, because that's kind of crazy. So here's a different way you can get the median. Because in this table here, all these numbers, these are in order. You have 0, 1, 2, 3, 4. They are in order. And underneath, you're just given the, that number of times that they occur. So there are 15 data values. So here's a trick. Divide 15 by 2, and you get 7.5. Round 7.5 up, that's 8. The median will then be the 8th data value. So let's look here. The first 2 data values will be 0, so that's 1, 2. The next 2 will be 1, so 1, 2, 3, 4, 5, 6, 7, 8. So the 8th data value will be 2. So that's a little trick so that you don't have to write out all the numbers, because that would be a little insane. The mode is 3 because there's the most number of 3s. There are 5 3s. Okay. So mean is 2.2, median is 2, and the mode is 3. Okay, let's talk about outliers. An outlier is a value that is substantially different from the rest of the data values, and it affects measures of central tendency, and they can be misleading because it can skew the representation of the data. For example, with the job offers, if there was like one kid who got 12 job offers, that would be a little crazy. That's an outlier. But it would drag the mean up. It wouldn't do much to the median, and it wouldn't do anything to the mode, but it would drag the mean way higher than 2.2. So let's look at this example. Which is an outlier for this data set? We have 56, 65, 73, 59, 98, 65, 59. Okay, I hope you guessed that 98 is the outlier. 98 is 25 more than the nearest data value. That's pretty high. And all the other data values are less than 10 apart. So 98 is definitely an outlier here. What measure of central tendency do you think this outlier would affect the most? Well, as we discussed up here with the job offers, an outlier will affect the mean the most, generally speaking. I think it's always true. Okay, range. A range of a set of data is the difference between the greatest and the least. So a couple new words here. Well, not that. You probably already knew that. Quartiles. Quartiles is 1/4 of a data set that is ordered. So it's already put in order. And the interquartile range is the difference between the third and first quartiles. Okay, we'll talk more about that in a minute when I show you how to find one. Okay, so you're going to need your calculator soon. Okay. Comparing data sets. The table shows the average monthly water temperatures for 4 locations on the Gulf of Mexico. How can you compare the 12 water temperatures from St. Petersburg with the 12 temperatures from Key West? So that's just these first 2 rows of data here. So you don't need to look at the other ones. That doesn't look very good though, so maybe I'll... Yellow? Do you think yellow will show up? I don't know. Oh, it does. Look at that. Oh, I bet I can make it straight too. Look. I love when it does that. Okay. So we're going to be looking at these 2. Okay. So the first thing we're going to do is we're going to find the median and we're going to find the quartile. So I'm going to show you how to do this. Okay. St. Petersburg. So the first thing we're going to have to do is put St. Petersburg's temperatures in order. And so here they are in order from 62 to 86. The first thing we're going to do, well, I guess it's the second thing we're going to do, is we're going to find the median. So if you notice here, there's 12 data values. So we're going to have to look at the 2 middle ones, these 2. So in order to find the median, when it's 2 numbers, you have to add them. So we have 74 plus 78 is 152, divided by 2 is 76. So the median is 76. And notice the median does not necessarily have to be a number that's in this list. Okay, the next thing we're going to do is split the data up into 2 parts. So the right half and the left half, or the lower half and the bigger half. So I like to do this. I don't know, it makes me happy, but I didn't like that, but okay. Find the first quartile by finding the median of the first half. So we're only looking at these 6 numbers. Okay, and we find the median of those 6 numbers. So the median is going to be, these are the 2 middle numbers, 64 and 68. So now we're going to have to find the mean of those. If you can do it in your head, feel free. You definitely do not have to do this math out. So I can look at 64 and 68 and just be like, the median is 66. But I'm sorry, the mean is 66. But you would divide 64 plus 68 by 2. And that would give us 132 over 2, which is 66. Okay, so that's the first quartile. So I label this Q1. Okay, then we're going to find the third quartile by looking at the second half of the data. So all these numbers from 78 up to 86. And again, we're going to find the two middle numbers, and that's going to be our median of the second set, which is the third quartile. And those numbers are the same, so you don't really have to find the average of them because you're just going to get 84. So the median of the second half is 84. The next thing we're going to do is we're going to find the min and the max. So the minimum data value for St. Petersburg is 62, and the max is 86. So this gives us a lot of different, analysis of this data. Okay, we're going to repeat the process for Key West. Okay, so first we're going to put the data in order, like I did there. We're going to find the median. So that's this right here. Those are the two middle numbers. I'm going to add them and divide by 2, which is going to give me 80. Then I'm going to find the first quartile. That's from looking at the first half of the data. And we're just going to look at the two middle numbers. And then we're going to find the mean of those. So that's 72 plus 75 over 2. It's 147 over 2, which is 73 and a half. And then we're going to repeat that for the second half of the data. And you can probably tell what the middle of 85 and 86 is. And that would be 85.5. The minimum of Key West is 69 degrees. The max is 87 degrees. Okay, so over here, I just organized it a little bit. So I have a list for St. Petersburg, a list for Key West with the minimum, the first quartile, the median, the third quartile, and the maximum. Hey, where's the second quartile? Ah, it's the median. So we call it the median. It's really the second quartile. But if you were wondering why he was missing, that's why he's missing, because he's really just the median. So here's all those data analysis numbers for St. Petersburg. Here they are for Key West. Now, I mean, I guess I can look at these numbers and be like, Key West is always, warmer or whatever. But what I'm going to show you now is how to take all this information here and to draw what's called a box and whisker plot. So this is where you're going to need your calculators. Look at that, I have pictures. Okay, so a box and whisker plot is a way to display the data that uses these quartiles and the mins and the maxes. So we're going to make a box and whisker plot, and we're going to use the same data we just did for St. Petersburg and Key West. So the first thing you're going to do is get your calculator, and you're going to go to Stat, Edit. So there's the Stat button there, and then you click number 1 for Edit, and then it brings you to List 1. So in case you forgot, if you have numbers in here, you can scroll up to L1, hit clear, and then enter, and then that will clear out all the numbers. So in L1, we're going to enter all of the data values for St. Petersburg. It doesn't matter if you enter them in order or not. That's up to you. I already had them in order, so I entered them in order, but it really makes no difference. And then scroll over to L2 and enter the Key West temperatures. Okay, so all the way down until the bottom. All right, next we're going to go to Stat Plot, and we're going to turn it on. So remember, I'm going to make this a little smaller. We go to Stat Plot, which is second y equals, right over here, I have arrows pointing to them. And then you get this window here. So you hit enter to go into plot 1. And then you go over here, make sure that you click on the on button to turn it on. And then you need to pick the box and whisker plot. So it's blacked out in this little picture. But if you look over here, that's the one that we're looking for. Now to get down there, so you have to scroll down to get the type. But then in order to choose the graph, you have to actually hit the right cursor button. You can't hit down or else it skips to the next list, the next thing in the menu. So make sure you're hitting the right arrow button. And then when you get over to the box and whisker plot, hit enter. Make sure that underneath X list says L1. Okay. Then when we're done with that, we're going to go to zoom stat, because remember, zoom stat just magically makes the window fit the box and whisker plot, which is pretty great because then you don't have to putz around with the window. So zoom down here. Zoom stat is number 9. And then there's the box and whisker plot. Look at that. Isn't it cute? Yeah, we used to do them by hand, but hey, why bother? Okay, so on this box and whisker plot, right here, it automatically brings you to the median, which it does say at the bottom. And if you use the trace button, which is here, you can trace along all of the important values on your box and whisker plot. So if you scroll over to the left, you can get the minimum is 62. And then if you scroll to the right, you'll get the first quartile is 66. See it labeled down there? That's kind of nice. And then back to the median. And then the third quartile is 84. And the max is 86. So isn't that cool? I'm really proud of my pictures. I hope you like them. Okay. So now let's make a box and whisker plot for the Key West temperatures also. So we already entered the data into L2. There it is. But we're going to put another box and whisker plot on. So we're going to go back to stat plot, except for we're going to go down to number 2 and go into this menu. So go down to 2 and hit enter. And now we're in plot 2, so you're going to turn that on. You're going to go over to type. Remember to hit the right arrow button to scroll through the graph choices. Choose the box and whisker plot. Now this part is different. So when you get down to X list, you need to tell the calculator that you need the numbers from L2, or else it's going to grab them from L1, and you're going to have two of the same exact box and whisker plot, which would be pointless. So you're going to need to type L2 here. So L2 can be found above the number 2. So look at your calculator to the number 2. If you look above it, it says L2. So you're going to hit second and the number 2 to get L2 there. And then this menu here, frequency, you just leave that alone. Okay. So now go to hit zoom stat again, just in case this new box and whisker plot doesn't fit in quite the same exact window as the previous one. I kind of think it does, but so look here, you can really compare them very well. It's a very nice visual. I don't know the purpose of box and whisker plots alone, really, but I totally get it if you're comparing two things. So this top one is the St. Petersburg water temperature, and this is the Key West water temperature. So you can see a couple of things here. So it looks like Key West is warmer. It definitely is trending more toward the right, so that's, a higher temperature. Also, I would say that it doesn't look like Key West's water temperature really varies that much. Notice that the box and whisker plot for St. Petersburg is just bigger overall, and that means that the temperature varies more. But what I want you to realize is that Key West is a whole lot farther south than St. Petersburg, so I got you this little map. See, here's Florida, here's St. Petersburg, and here's Key West. So it might not surprise you once you see a map that Key West's water temperature wouldn't change as much as St. Petersburg, because they probably don't experience, like seasons, in Key West. I mean, they probably don't in St. Petersburg either, but I guess there's, a little bit more of a difference. Okay, the next thing we're going to talk about is percentiles. And these are very important, especially when it comes to tests, because it's like, oh, you scored in the yada yada percentile. So what is a percentile? A percentile is a number, which we'll call X, between 0 and 100, and it shows the percent of data that are less than or equal to X. Better with an example. So if a student scored in the 85th percentile on a standardized test, I feel like I forgot there we go. In the 85th percentile on a standardized test, then that student did as well or better than 85% of all the students taking the test. Or you can look at it as only 15% of the kids did better. Okay, so here's an example. This is an ordered list of midterm scores. What is the value at the 65th percentile? Well, I don't know if you can see this by looking, but it's not going to be 65. Oh, they want me to call it. We'll just ignore that. Okay. Every time it underlines these numbers, it thinks I want to call somebody. I don't understand it. Okay. So the first thing we're going to do, and I have directions here, is we're going to count the number of data values. So if you count these, there are 20 of them. The next thing you're going to do is you're going to find 65% of 20. Because 65, oops, that's not the one I wanted. 65 of 20. And that is 13. So now the list is in order, so that's good. So you're going to find the 13th number in the list. So 1, 2, oh, there we go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what that means is that an 82 on the midterm exam is at the 65th percentile. See, so that just because you got an 82 doesn't mean you scored in the 82nd percentile. So let's try another one. Find at what percentile a score of 80 is. So this is a little backwards because I didn't give you the percentile. I asked you what it was. Okay, so the first thing we're going to do is find where 80 is on the list, like which number is he in order. And he's the 12th. I'm going to add that in there because that's kind of confusing. So 80 is the 12th data value in the set. So next you're going to find what percent is 12 out of 80. So, I'm sorry, 12 out of 20, my bad. So, and 12 out of 20 is 60%. So that means that an 80 is the 60th percentile. Okay, one more. What is the score at the 95th percentile? Okay, so let's see if we can remember what to do without looking. So first, we know there's already 20 values because this is the same set of data. So first we're going to find 95% of 20, and that's 19. And then we're going to find the 19th number on the list. That's 98. So that means that 98 is the score at the 95th percentile. And that's it. I hope you enjoyed today's video. And next time we'll do standard deviation. Ooh. So now you should definitely